All right, it's Mr. Collins here, doing a series of videos on sums of infinite series, and we looked at the warm-up and the first problem on this handout. Again, the handout you can get from Schoology, and just keep in mind you can pause the recording, fast forward, rewind, whatever you need to do to catch up and see what's going on. So the second one, again, it says, look at the partial sums. And what am I going to do? I'm going to look at the sequence, and then I'll look at the series. So I got the sequence, and the sequence means, hey, plug in 1, plug in 2, plug in 3, see what happens. So you plug in 1, you get a half. Plug in 2, you get a half squared, that's a quarter. A half cubed is 1/8, and then 1/16, and then 1 out of 32. And fairly obvious, the sequence has a limit where it converges to 0. You can see it keeps getting smaller and smaller and smaller. You'll never quite get to 0. It'll get infinitely close. But we're interested in the series, right? That sigma out front says add things up, and on the top, the indexing variable goes to infinity, means we just keep going and going and going. So what does that mean? Well, for the series, it means we're not really putting commas between these terms, we're putting plus signs, so we're adding them up. So of course, the first term of the series is still a half, but the second term, you're adding up 1/2 and 1/4, which is 3/4. And then the third term, you're taking the first 3, or you're really taking 3/4 and you're tacking on 1/8. That gets you to 7/8. And then you could see what's happening again. You got 15/16. You got 31 32nds. So if you look at it, the bottom, you have a power of 2, 2 to a power. And on the top, you have just 1 less than that number. So, and you could actually write a rule. This would be what? 2 to the nth power, and the top would be what? 2 to the nth power minus 1. That's kind of what's going on. That's just a little extra for you. Either way, look at the numbers, right? 1/2, 3/4, 7/8, 15/16, 31 out of 32. So this series, what does it add up to? It gets really, really close to 1. And so the series converges to 1. That's the term we use when a series has an actual sum, right? And in order for a series to converge to anything, the sequence has to converge to 0. Why? Because each term has to you have to keep adding really teeny tiny stuff. If the sequence doesn't converge to 0, you can't have a series converge. I hope that makes sense. The whole key to this is you move along in the series, the numbers you keep adding become infinitesimally small. Like the fifth term is only 1 out of 32. The next term will be 1 out of 64, and then 1 out of 128. You keep adding like little grains of sand, and it's not making much of a difference in the sum. So that's kind of important. All right, look at this third one. First of all, you got to figure out the pattern. Hopefully you figure out as you go from 6 to 2, you're dividing by 3, or I'm going to more succinctly say you're multiplying by 1/3. So that's like a common ratio. So this is just like the last one. You keep multiplying by the same number. It's a geometric series, and it goes on forever. So this is an example. I'll write it below here. This is an example of an infinite geometric series. Okay. And really, these are the ones we focus on because they have a neat little formula. Okay. If you kind of look at this, right? And this time I'm just going to look at the series. Yeah, because the terms are actually written there already. The series starts at 6. If I add 2, I get to 8. If I add 6 plus 2 plus 2/3, I get to 8 and 2/3. And then if I add a 2/9 to that, if I add, basically if you're adding 2/3 and 2/9, you're going to end up with 8/9, 8 and 8, 8 and 8/9, 8 and 8/9. And then after that, you're going to be adding 2/27, which is going to be, believe it or not, it's going to be 8 and 26 out of 27. And I think you can see, hey, what's getting close? You know, we're not really going to get above 9, are we? We're going to get this 8 and 2/3, 8, 9. You could see that you're going to get really, really close to 9. That's what it's getting close to. And kind of what we're working our way towards is this infinite geometric series. And it only works for infinite geometric series. It has a cute little formula where we have the first term over 1 minus r. And it only works, and actually it's kind of written on the next page of the handout here. I should probably highlight it here. It only works if the common ratio is less than 1. Because why? If the common ratio is less than 1, those terms get smaller and smaller and smaller. Think about, if you multiply by a number less than 1, the next number is smaller than the original number. So if I look at this, you know, the first term here is 6, and the common ratio is 1/3. And what do you got? 6 divided by 2/3. And don't forget, when you're dividing, you're actually multiplying by the reciprocal. So you're multiplying by 3/2. So you get 18/2, which is 9. So the math, man, the math is simple. I mean, look at, here's your equation. That's easy peasy, nice and easy. But what do you have to recognize? You have to recognize that you have an infinite geometric series. Okay, so in the next video, we'll look at a couple more examples of those. So we're going to stop the recording right now. Hope this one helped. One more recording coming up.